All right, ladies and gentlemen, our first mechanism. So here's the thing. Here's the thing. You can do your journal tonight for the whole semester if you want. All you have to do is find a mechanism like this one in the textbook, and they're always in shadow boxes. I hope you know what I mean. Nope. Oh. Okay, well, you see it'll say mechanism in a box. So some box surrounding something here, and it's shaded in. And those are mechanisms in there. You'll see curved arrows. If you don't see curved arrows, it's clearly not a mechanism. But they're in the textbook, and I need the section. Okay. And in this one, if you wanted to be a journal entry, 6.1a, electrophilic addition of HX to alkenes. That might not be the title I used. You want to use the one straight from the textbook, please do, because I don't trust my memory anymore. The only thing I can guarantee is that's probably not the title, okay? But it has the parts. So copy whatever my title is for 6.1a and copy the shadow box. That's all mechanism journal is. Your first good mechanism for a new reaction. And it better be good or you didn't copy it right. Don't copy what you do by hand. I don't even give you that option. Because you're just learning, you're going to make mistakes. You're going to be doing outer space stuff when you don't even think you are, right? So you go from the book, or you can use my notes from online, the ones we're making right now, and you could use this as an entry for your journal, okay? And anybody want to take a stab where the first arrow starts? Because we did a reaction that started with an alkene and HBr. We did one. Alkene, HBr. So do you remember those two arrows? First arrow started where? Pi. Ended where? Proton. And that word is the answer to why did you go that direction and not the other? What charge does a proton have? Positive. What's the only thing electrons are attracted to? Positive. You can't get the arrows backwards when one of the atoms is slightly positive. I'm going to write it down, but erase it. You don't get points. Do you agree the H is slightly positive and the Cl slightly negative, just based on 2.1 electronegativity versus 3.0? H, 2.1. Cl, 3.0. You didn't memorize it just for test one. I got bad news for you. It's supposed to be for every test. So we don't have to stop and review electronegativities to figure out which way arrows go and then start the arrow. Okay? My favorite example is you don't want to look up the definition of the word and every time you see it in a book. That's how fundamental the electronegativities are. Also pKa's, same story. I don't want to be waiting for students to figure out carboxylic acid 5. Okay, the equilibrium's going to go that way, not that way. All right. So the students that say mechanisms make absolutely no sense, they got to try to remember the stuff they learned before. These are electrons. They're attracted to positive. Don't draw them towards the Cl. The Cl is negative. Okay, and what was the second arrow? Do you remember? On the sigma bond towards the Cl atom, right? You get three products, really. And I'm going to do it test version, which can be misleading because stick figures don't show the atoms, right? But I'm telling you, if I put the H on this carbon here, then this carbon loses the fourth bond and becomes a cation. I'm going to draw the H temporarily. This H is new. It was not there before. This H was old. it was there before. Okay? You do not need to show me either one of those H's. They are going away. They didn't go away. These are stick figures. That's a CH2. How do you know there's no H's on this carbon? I have 3 bonds and no lone pair. If there was a lone pair, it would be an anion. If there's no lone pair, it's a cation. If there's a fourth bond, which there isn't, it's neutral. Okay? So there's that. And what's the other product you made when you reacted HCl to make this? Cl with one new lone pair that I need later. So that's one product. Now, if you put the H here, where's the cation going to be? On the top. Ladies and gentlemen, I don't even want you drawing that H. I am losing 0 information by not drawing the H. There is an H there, or else it would be a plus charge, right? Okay. You do know there's a new H there. Please. There was no H on that carbon to start with. None. 4 bonds showing none of them hydrogen. There's a new H here. That means the other carbon lost its 4th bond. The 4th bond was to the pi to the other carbon. It's gone. You are now a cation. And when you made that product, you also made a Cl minus. Okay? And then tell me how to finish the mechanism. 2 more arrows. That's it. 1 for each product. Yes? Yes? Oh, don't say it that way. I'll do what he said and show you why I'm losing a quarter point. No, I'm glad he said it. I'm going to do what he said. He said ended at the carbocation. You just lost a quarter point. Your arrow did not end at an atom. No. So you can either ram it right through the plus, which, you know, it's perfect. It's great, but it's notes and it's confusing right now. So I'm just going to go on a slightly different angle, clearly ending at the carbon, right? You don't want to be finding out how picky I am. Just make sure it ends at the carbon exactly. Okay? Same story here. It's ending at the carbon. It did not end at the cation. No. It ended at the carbon atom and made a bond. And that's the end. This is not a hard mechanism, is it? I know. It's hard because it's like a new language. But it's over. So if you want to use this for your journal, that's it. Right here is a journal entry. You may use this as a journal entry. You can carefully copy this into your journal. You can copy this exact one right here from the notes at Moodle, not from what you're doing right now. No, don't trust yourself. You're just starting. Just telling you, don't trust yourself yet. Okay? Okay, no mistakes here. I didn't ask for labels. Only one question on your test. Are you going to do the Lubnu Habibi stuff? Okay? Just the one, and it's a lot of points for little things. Each label is a half point, and sometimes there's like 30. So that's quite a bit. So labels are fun, but you don't get to do them on every mechanism. And there's that. And I better save this somewhere safe. And stop the video. Yeah, we're going to talk about major and minor very soon.